we have a circle equation as shown, and then another straight line where we're told it's a tangent, and we're asked to show that M satisfies this equation here. So when tangent and circle touch, remember they're going to intersect. Actually, they're just going to intersect in one place, just touches. But when they touch, I can write down, I can substitute in and now I've got a quadratic. And where are we headed? Well, we're not going to solve this quadratic, but like directly, but we know that discriminant must equal 0. There must be a repeated root to it because they just touch. Okay, I'm going to bring x squared terms together. And the x terms together. And then finally, I'm going to subtract 13 to give a plus 3 here and add that on to 49. Now, I can see a little trick here. We can actually, like, it'd be tempting to just multiply all this out. Some of the numbers get quite big, so we can actually factorize a 2 out of here. And then we can square the whole thing. That's the same, and it's equivalent to squaring each term separately. So that what I'm saying is this term here is exactly the same as this term here. And now I've got a common factor of 4, which I can cancel out. I'm going to get minus 28m and another lot, so that's minus 56m. When you get this sort of thing, that's great news, because in the question it said to have a 3m squared. Okay, I got minus 3m squared, but it will sort itself out. So 52 minus 16 is 36. It's going to be minus 36. Now let's just look back at this. We had 3m squared plus 56m plus 36 equals 0. And that is precisely what we get if we just either just multiply through by minus 1 or get it all onto the right hand side. Okay, a bit of algebra manipulation, but that's a nice start to this question. So part A done. We're then told that the tangents from the origin to C1 touch C1 at A and B, and we're asked to find A and B. I was hesitant there because I also need the equation of the circle. I'm just going to do a little sketch of what's going on. We have that the center is going to be -4, 7. And the radius is √13, which is going to be less than 4, by the way. So if I go -4 and 7 up here, then I'm going to get a circle. I'm not actually going to go through the axis. Okay, a little bit like that. And then the tangent from the origin touches in 2 different places. So that's going to be here and here. By the way, both of these equations will be in the form y equals mx. So we're going to be using what we had previously. Okay. We expect this to factorize. If it does, it's got to be a 3m and an m. Now it's just a case of, well, trying some numbers. So what is going to work? We've got 36. We can split that into 12 and 3. 12 would have to go over here. That's not going to work. We could go with 4 and 9. That wouldn't lead to an even amount here. Another one is 2 and 18. So 3 times 18 is 54. And then 2 times 1 is 2. So that is going to be what we have to go with. M plus 18 and 3m plus 2. So m is going to be -2/3 or -18. This is good because you could see from the diagram that we've got negative gradients, and one's going to be steep and one's going to be much less steep. Hence, the tangent is going to be y equals -2/3 x or y equals -18x. There are 2 ways to do the next part. Remember, we're finding the coordinates. You can kind of do it like by looking at the diagram geometrically, or you can use implicit differentiation. I got to admit, I used implicit differentiation. I think it's more complicated, so I will go through that, but I'm going to show you the other way first. So what we can do is we can draw from the center. Remember, the center is -4, 7. We can draw radii from the tangent to the center and then to the origin as well. Now we know these lengths, they are √13. We don't know either of these 2 coordinates. So I could call them x, y for each one. I'm just going to call them the same sort of thing. Then we can also figure out this distance, because it's just going to be -4 squared plus 7 squared, square rooted using Pythagoras Theorem. And hence, if I want to know this distance, well, that's just going to be, so this distance here is going to be root x squared plus y squared. Now, the one thing I've not mentioned is that these two are right angles, so I can use Pythagoras Theorem on these triangles. So when I square this, I just get x squared plus y squared. When I add the square of root 13, it's just 13. And I'm going to get the square of root 65, which is 65. Remember, this is for A and B, where the tangents touch. I'll deal with the minus 18x to start with. We're going to get x squared plus, okay, I'm going to need to square that minus 18. Okay, let's see if we can cancel this down. So 52 is 2 times 26 or 4 times 13. Now 4 does not go into 325, so we need to just see if 13 does. We're going to get 26, so 2, remainder 6. And 13's into 65 go 5. So that is going to be 25 times 13 x squared. And cancel the 13's out. We know that it's where x is less than 0. So then y is going to equal 36 over 5. And let's call that A. We've now got to do the same again, but when y is equal to minus 2/3 x. So if I square this, I get 4 over 9. And that, I think, was equal to 52. So that's going to be, this is 9 over 9, so it's going to be 13 over 9 x squared equals 52. Remember, it was 4 times 13, so I can again cancel the 13's out. Okay, this one's much quicker. X squared is going to be 36, so x is going to be minus 6. and y, if we find a third, it's going to be minus, it was minus 2/3. Find a third, it's going to be minus 2. Times that by minus 2 is going to be 4. Okay, and we're done with this question. It's quite a lot of like little equations to solve and arithmetic to do, but we've managed to find the coordinates of the points A and B. Now, before I move on to C, I did say that there was another way of doing this question, so I'm not going to go through the whole thing, I don't think, but I'm just going to talk about it a little bit. We have the gradient of the tangents. Here's the other way of thinking about it. The gradient of the circle will be the same as the gradient of the tangent at the points that we're trying to find. So that just means we need to find the gradient of the circle. And that we can do it from the equation of the circle. So method 2. This can be done by differentiating implicitly. So I don't even need to expand the brackets. I can just go for it. Method 2, differentiate. Okay, left-hand bracket's quite nice. Right-hand bracket's not too bad either. I can cancel out these 2's. And then I can subtract the x plus 4, divide through by y minus 7, which we could write as x plus 4 over 7 minus y. And here's the key thing. This equals m when y equals mx touches the circle. So that means m times 7 minus y is equal to x plus 4. Without doing the whole thing, basically you could just solve this simultaneously. So when y is equal to what is it, 18 minus 18 x, m is equal to minus 18. I can then substitute that into here, and I've got an equation for y and x, but I also have this equation here because they're intersecting in the same place, so I can solve these simultaneously to give me the coordinates. I can then do the same for y equals minus 2/3 x. I won't go through the whole thing, but you might like that method as an alternative. For the very last part, it's only 2 marks, by the way, so it's not going to be really complicated. That's one thing to note because it looks, not easy when you first see it. So another circle has this equation: the tangents from the point 4 minus 7 to C2 touch it at the points P and Q. Find the coordinates of either P or Q. Now, we need to think about what's going on. We've just done a question where we had the tangents from the origin, and now it's talking about a similar kind of circle, because you can see the similarity, but actually it would be worth just seeing how is this the same as this? Well, actually, going from here to here, I'm just going to write this down. It's going to be a translation. Going from here to here, it would be minus 4, wouldn't it? Because you could put in a plus there. So to go the other way will be 4. And then here to here would be positive 7. This is going to be minus 7. So basically, we've translated the circle by 4 minus 7. And we've also essentially translated the point that we're interested in. We're interested in it, going through the origin. And now we're interested in going through 4 minus 7. So basically, we just need to translate the points that we found in part B by 4 minus 7. So the simpler one, well, we had B and we had A. A had fractions in, so let's just deal with B. B minus 6, 4 will translate to minus 2, minus 3. We'll just call this one Q. You could do the other one if you wanted by adding 4 and minus 7, but we're just asked to find one of them. Okay, well done.